Welcome back to today's live. Yesterday, we were able to go through the top 5 topics you expect in WAEC this year, and we started with electricity, and then we proceeded to motion as number 2, then waves and sound, number 3, then light and optics, number 4, then we ended with number 5, fields, which include gravitational, electric, and magnetic field. Today, we want to complete the top 10 topics that you would expect in this year's WAEC and even NECO exams. So, we are proceeding with number 6. For number 6 is thermal energy and gas laws. This is a very important topic that you would expect from WAEC, and you expect 1 or 2 questions from this. And one principle you must know is that heat is energy that flows from a hotter body to a cooler body. There has to be a transfer of heat from a hotter body to the cooler body. And during this process, you'll be asked for specific heat capacity because it is the heat needed to raise 1 kilogram of substance by 1 degree Celsius. And also, after this, then we will now head to gas laws. But quickly, under heat energy and heat transfer, there is a laboratory instrument called the calorimeter. We use this to determine the temperature change based on substance, from hotter substance to the colder substance. So calorimeter is used in calculating heat capacity. And our formula, basically, the formula you need to know is Q equals mc delta theta, right? Where Q is the heat in joules. So Q is the same thing as E, and E is energy in joules. All right? So Q is heat energy, and then M is mass in kilogram, C is the specific heat capacity in joules or per degree Celsius. Then we have delta T to be change in temperature. Alright, so with this, you should know that for calorimeter mixing formula, this is how your formula will look like. Okay, now observe, you have the part that is coming from the hotter substance. Okay, from hotter substance. Then we also have the part that is coming from the colder substance or the cooler substance. Alright, so for this is for hot substance or hotter substance, and this part is for the cooler substance. Okay, or we can say colder substance. So as heat is being transferred, it has to come from a source and then it lands on the receiver. So this is the source of the heat and this is the recipient of the heat. Okay, so that T1 is the initial temperature of hot body, T2 is the initial temperature of cold body, and then TF is the equilibrium temperature, which is why you are seeing TF here and TF here. Now observe something. Let me tell you a secret quickly. While doing this, you should know that the equilibrium temperature is connected to both the hotter substance and the cooler substance. For hotter substance, the equilibrium temperature becomes the final temperature. Okay, or it becomes the smaller because we have T1 to be greater minus the smaller. Then for the cooler substance, the equilibrium temperature is meant to be greater than the final temperature. Yes, so take note of this based on heat transfer. And then one thing you should know is this: with this particular formula, okay, you can be able to solve your problems. Now, or in case you forget this particular formula, from your question, if your question comes out under this topic, you can easily be able to recall this particular formula. How? You can recall it if C is given to you. because most of the time C is constant, and hence they'll give you the value of the constant and it will come with this SI unit. So all you need to do is over divided by mass times delta. Are you getting this? So that is how you get your formula in case expansion occur when a material increases in size due to heating. Now all this occur because of heat. Now let's V and T are present. So the constant will not be in the formula. The constant will be eliminated. But in the whole scenario, the secret to all these formulas, look at it. It is constant, okay? Your constant 1 equals your constant 2. That is what's happening here. Constant 1, K1 equals K2. So this part is K1, this is K2. K1, K2, K1, K2. That's how all these formulas are gotten. You are equating the same thing to each other, but initial to final. Yes, that is it. Hence the formula. So please memorize some of these formulas because they will help you. Then for combined gas laws, okay, T are present. Is T constant equals combined gas laws. It is the combination is constant. Gay-Lussac law, what is constant? V is constant. Inversely proportional. Inversely proportional. Now check. What do you have here? You can see that T is inversely proportional here from this. Are you getting the logic here? I'm opening your eyes to see how these formulas are generated. Then for Charles' law, it is directly proportional, which is what? P is directly proportional. So you expect it to be the numerator. Now observe, P is the numerator. Look at this, pressure and temperature are directly proportional for Gay-Lussac law. Now look at it. Can you see the arrangement? So what they did is that they combined all the constants in all the three laws together. Then what happens? They now followed the proportionality law in each of the law to arrange the constants, and that helps in deriving this general gas law. Then for Avogadro's law, we have V1 over N1 equals V2 over N2, right? Then volume is directly proportional to the amount of moles of gas. Please take note of all this. Then ideal gas law, PV equals nRT. These are basic formulas you need to understand. I'm doing this for you so that you don't have issues, because when I give you question, they will expect you to use either of these, and if you don't know some of these things, then it will be very difficult for you to understand. Then I also captured linear expansivity under this because it relies on heat. All right, so for linear, okay, we have delta L equals alpha L naught delta theta, and these are the interpretations to this. Then for area expansivity, okay, we have this. What is the difference between this? Just your area, that is all. Then beta is being introduced here. Here alpha is introduced, beta is introduced. Then for cubic expansivity, which is volume, we have V and gamma being introduced into the formula, but the formula takes the same shape. You can see them here. So relationship between coefficient, beta is 2 alpha. Once you are given alpha, you can use the value of alpha to find beta by multiplying it by 2. All right. Then for gamma, if you still have alpha, you can multiply alpha by 3 to obtain gamma. All right. Please understand this concept and apply them. Heat flows from until they get to the equilibrium temperature, where the temperatures are between them again. So practice problems regularly and understand the law and use them perfectly. With that, we can come under electrical energy. Can come under electrical energy, where electrical energy is being transferred or transformed into heat. This one into light, potential into kinetic, and kinetic into heat. It is possible because work is done when a force causes an object to move through a distance. So you have distance. You must cover a distance before work can be done. So energy is the ability to do work. I will know that power is the rate of doing work. The difference between the formula of work and energy, there is no difference. They are the same. Right? Then the formula for power, the differences is that the you can find work and energy in power, and then is the rate of doing work. You have to consider time divided by time. So meaning that when you are applying power, you are thinking about time. You are thinking about efficiency. That's where power comes in. Yes, efficiency comes with power, right? Energy can be converted from one form to another. Simple machines make work easier, and in under machine, we know that we have mechanical advantage, we have velocity ratio and efficiency. We are going to see that as we proceed. Then, but for work and power, you can see that our work is force multiplied by distance. The force you apply on an object and the distance that the object covers gives you work done. And if there is an angle, then work equals force and distance cos theta. All right. Then you should also know that for power, power is work over time or energy over time. Or you can say power is force times distance over time, depending on the parameters given to you. Take note of all this. Then for simple machine, you can determine the mechanical advantage, the velocity ratio, and the efficiency. How are you going to achieve that? You can achieve all this by simply knowing the types of machine. All right. For pulley systems, we have the single fixed pulley like this one. You can see the effort and you can see the load. So our mechanical advantage equals 1 and our velocity ratio equals 1. All right. Then for single movable pulley, this is fixed. It means that this is not moving. But for this is movable. All right. So this is movable. Hence we have effort and we have load. So our mechanical advantage becomes 2, our velocity ratio is 2. For block and tackle, where N equals number of supporting rope segments, you can see number of supporting rope segments. Then we have our effort and we have our load. And our mechanical advantage equals N and velocity ratio equals N. Now, you should understand that these formulas come in the form of force. Okay, if you are looking at it, effort is force, load is force. So we are just saying force divided by force. I'm going to show you as we proceed. Observe this. Observe this. You can see the man now pulling or dragging this on the hill. Is going this way. Now you can see there is a height here. You need to consider this height. Then the length of the surface is this. Hence we have length of inclined plane, we have the vertical height, we have the effort, and then we have the load. This is the effort in pushing the load, and the load itself has its own weight that will try to pull it downward. So mechanical advantage will equal load over mechanical advantage will equal length over height, and velocity ratio will equal length over height. Please take note of this particular formula. Now, look at this basic formula, the basic formula here. Look at this basic formula. Now, you can see mechanical advantage is given by MA is load over effort. This is force, force against force. Yes, force against force. And then velocity ratio is distance moved by load Distance against distance, work output over work input. That's what it means. Velocity ratio, that's what it means. Then pulley, for example, if a block and tackle has 4 supporting rope segments, the load equals 800 Newton, effort equals 200 Newton. How are you going to find the mechanical advantage? You will say what? Load over effort, which will give you 4. Alright, the velocity ratio is 4 because of the number of supporting ropes, and number of supporting ropes equals 4 over 4 multiplied by 100 to give you 100% when it comes to efficiency based on this. So the inclined plane, all right, for example, if we are solving any problem under this, you will see that the length is 5.0 meters, height is 1.0 meters, the load is 300 Newton, and if you are asked to find mechanical, this gives you your efficiency. So remember that machines do not reduce the amount of work done. They only make it easier by increasing force or by increasing distance. This kind of question can come in OBJ. Yes, it can come in OBJ. Just try to understand the concept of machine and take note of all this. They are very, very important. Now we go to number 8 topic now. Number 8 topic is Newton's laws of motion and momentum. This is a topic that you would expect questions from. Yes, because Newton's law, the first law states that an object at rest stays at rest and an object in motion will stay in motion with constant velocity unless acted upon by an external force. Now, you can see that this law is also called the law of inertia. So Newton's law describes the motion of objects and the forces that causes them. That is the simple explanation of Newton's law. Then for second law, we now have a formula attached to it. All right, we have a formula attached to the second law. And what is it? The Newton's second law states that the net force acting on an object is equal to the rate of change of its momentum for constant mass. So if mass, the object, is constant, then we have force here, and then acceleration comes in. Hence, you can see that this is another layer of work done. Okay, so we have force equals mass multiplied by acceleration, and you have the following. So that is how the second law is captured. Okay, force equals mass multiplied by acceleration. Now, the third law, for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. That is what the third law states. So FAB equals minus FBA, so that everything becomes 0. All right. Now, momentum is the quantity of motion of an object. The quantity of motion of an object gives you momentum. So these laws explain how forces and mass affect motion. They are the foundation of understanding the real world scenario of motion. Now, let's look at momentum, the formula quickly. You'll see that linear momentum is represented by P, okay, and P equals mv, so that P is momentum in kilogram meters per second, and m is mass in kilogram, and v is velocity in meters per second. After momentum, we have impulse. We have what we call impulse. Some textbook will use letter I to represent impulse, right? But here we are using J to represent impulse. Please take note of this particular stuff. So impulse equals first force multiplied by delta t, force multiplied by change in time. So you have your impulse, you have force, average force, multiplied by change in time. And when you do this, you'll see that the impulse momentum will give you, the impulse will equal delta p. Okay, impulse will equal delta p. And if you expand this, you have m into vf minus vi. It's just like saying v2 minus v1, or you are saying v minus u. Take note of all these explanation and interpretation. Conservation of momentum in a closed system with no external force total momentum before collision equals total momentum after collision. So take note of this. Under this, you see this how your formulas will be formed, and remember them because they can give you question from this. Let's look at one question from each. Example 1. Applying F equals ma, a force of 50 Newton acts on a 10 kg object. Find its acceleration. It's as simple as this. You make acceleration the subject of the formula. Then we'll move to the next one. A boy pushes a wall with 100 Newton. What force does the wall exert on the boy? The wall exerts 100 Newton in the opposite direction based on Newton's third law of motion. And then we have a 2.0 kg ball moving at 5.0 meters per second collides with a stationary 1.0 kg ball. After collision, the first ball moves at 1.0 meters per second. Find the final velocity of the ball. So it's just like you're finding V2. That is what the question is asking us to look for. Find V2. So you have M1U1 plus M2U2 equals M1V1 plus M2V2. So that you have this process. You should know how to make one of the parameters the subject of the formula. Sometimes one of the things that kills students or make student to fail is how to make a particular parameter the subject of the formula. So take note of all these particular aspects and what you need to do in order to get the correct answers. So inertia depends on mass. More mass, more inertia. So as mass increases, inertia will increase. OBJ question can come from this place. Then force causes a change in motion, which is acceleration. Then momentum depends on both mass and velocity before it can act. Then in a closed system, momentum is conserved. Alright? Note all these points. Then number 9, we have the atomic and nuclear physics. This is SS3 basically, but you should know that one or two questions can come out from this particular topic. Atomic and nuclear physics study the structure of atoms, radioactivity, and how energy is quantized. And radioactivity is the spontaneous disintegration of unstable nuclei. All right. Now, types of radioactive decay, we have the alpha decay, we have the beta decay, and we have the gamma decay. And these are the nature of your formulas. Observe this. Radioactive decay releases energy. It gives out. So it means you subtract. Energy in atoms exists in fixed level, which we call quantized. Electrons move between energy levels by absorbing or emitting photons. Alright, so take note of this. A equals delta N over delta T and can give you lambda N. This is one of your formula that you can use where A is the activity, alright, N is the number of undecayed nuclei, and lambda is a constant in per second. Then half-life operates in the form of T over 2, which is T over 2 equals ln 2 over lambda, while ln 2 is a constant value that I can obtain based on this. Alright, then radioactive decay law. This is the law. Take note of this. NO exponential negative lambda T. Take note of all this, where NO is the initial number of nuclei, the N is the number after time T, and T is time in seconds. So energy quantization, how does it happen? Number 1, you can use Planck constant or Planck's quantum theory to explain or understand or solve the problem, because energy is emitted or absorbed in pockets called quanta, and this is your formula. E, which is energy, equals H multiplied by F, where your E is the energy, H is your Planck's constant, and this is your value, and F is the frequency in hertz. Then photon. Now, photon, we have this formula gotten from this, transformed into this by substitution. You have this because you are saying E equals HF. Then we have hc over wavelength. Why? Because we know that v equals f lambda. V equals f lambda. So if you are bringing in v, because here c equals f lambda, this c is the same with this v. Take note of these. Then we have what we call energy level in atoms. Energy level in atoms. Electrons occupy only certain fixed energy levels. Then transition between levels involve absorption or emission of photons. And for energy level, you have this particular formula for the transition. We have the final or the total equals the final minus initial. Okay, or you can say higher minus lower, which gives you this. And it's the same thing as HF, and the same thing as HC over wavelength. So you have three formulas here captured in one. So let's look at an example of how nuclear equations look like for decay. For alpha decay, this is how your equation will look like. All right, this is how your equation will look like. With this helium particle, what you do, you subtract 4 and subtract through 2 from this particular element. Then for beta decay, you have this. You see this, you have subtract this is the part where you apply the principle of subtraction. All right. Then for energy level diagram, you can see the levels here. We have the E1, the ground level state. We have the second level state, which is E2 minus E1, and then we have the third level state, which is E3 minus E2 photon being emitted at this level. So electron falls to a lower level and photon. Take note of all these principle that occurs during processes. Then look at this example. This question can come in this format. T over 2 will now give you this. All right. A photon has 6 E equals hc over wavelength. You can use this to calculate for. All right. So basic information you must remember. Note that radioactivity is random but follows an exponential law. Alpha particles have the highest mass and lowest penetrating power. All right. Beta particles are lighter and more penetrating power. Gamma rays have no mass or charge and are the most penetrating. Get the differences. Energy in atoms is quantized. Electrons cannot exist between levels. So radioactivity, unstable nucleus. Decay constant, probability of decay per second. Shorter half-life, faster decay. Photons carry energy and higher frequency, higher energy. All right, take note of all these. Then we'll move to the last one now. Very important, very critical, very nice. We have the vector, the scalar, equations, and SI units. So quickly, this is part of SS1 work. One or two questions can come out from this particular aspect. Okay, for scalar, they have we have mass because they have magnitude only. They can be measured, but they have no direction. They have no angle. Right? That's the differences. But for vectors, they have size. They can be measured and they have angles. They have direction. So these are the examples of scalar and vector quantities. And I know you know most of them, but you should be able to list them. So physical quantities are either scalars or vectors based on classification. Scalars have magnitude only, while vectors have both magnitude and direction. Physical equations relate to quantities using symbols and mathematical operations. Then we have dimensional analysis that checks the correctness of equation. And then SI units are the standard units used in science and engineering. All right. So differences between scalar and vectors, you see that this is measured. It is measurable 5 meters. This is 5 meters measured, and then direction east. So this is the difference between vectors, and scalar quantity. Hence, you should know that the general form of an equation can come in this format. Okay, then you have your equations of motion coming into this. All right, take note of these basic equations, formulas, even though they are not under this topic, but you can be asked for dimensional formulas from these. But based on quantities and dimensions, we have quantities like length, taking the symbol as L, dimension is L, SI unit meters, and this is a symbol. So you can see all of them here. Take note of all this. Go and practice dimensional formula. One or two questions can come from dimensions. And once you know them, then automatically you'll be able to solve your formulas, all right? Or solve your questions. Rules of dimension. Look at this rule. If A equals B, then open bracket A close bracket equals this. So what it means is that you put them in brackets. All right, these types of brackets, they are what you are going to use for this particular rules, not the curly or curve bracket, but these are the curly brackets. You use them in this dimensional formula. Take note of all this. Then I gave you this table so that you use it to practice. If you are with your phone, you can screenshot this now, okay, so that I look at some of the quantities, look at them, then you practice them. Is that clear? So you can screenshot this particular table for your exams. These are basic quantities you are meant dimensional analysis for force and for period when a pendulum. Okay, these are what you are having. Take note of all these principles, and if you have questions, you can drop them in the comments. So I wish you all the best in your exams. Tomorrow I'm going to organize a live where I'll give you tips and tricks on how to easily answer physics question and to save your time in exams so that you will not waste your time while writing physics exams. So do well to join us in our live. It promises to be interesting, it promises to be educative, and promises to be enriching. I will see you in the next one.